Okay, good morning. Welcome to
FunMath129.
That's number 129. Having a little camera issue. Okay, so today we're working on, we're still in section 6.2 of Art of Problem Solving, algebra book, and we're working on clock problems because we had a little bit of trouble with it yesterday. So, here's the question. What is the first time after 3 o'clock that the minute hand and the hour hand of a clock point in the same direction? Okay, so do you understand the problem?
Yes.
Okay. So we're trying to find the first time after 3 o'clock that the minute hand and hour hand point in the same direction.
So they're on top of each other?
On top of each other, yeah, pointing in the same direction. So could you please draw for me about what time that is?
I think it's going to be like the hour hand's going to be about here. And the minute hand. I'd say around 3:16.
Okay, so it looks like we're going to say this is about 3:16. That's our guess.
But
Now we're going to try to solve.
3:15 is less than on time, which is less than 3:20.
Right, 3:15. It's between 3:15 and 3:20. It looks like it's about 3:16. Okay, so how are we going to solve this equation? What are we going to do?
Well,
Come here.
well, we know the minute hand speeds and the hour hand speeds.
Okay.
So those don't really come into play. Well, the minute hand at any given time is 0 plus 6t. That's t is the time.
Okay, what does 0 plus 6t represent for the minute hand?
It represents where the minute hand is.
Not quite. It represents something, and it represents something very important in the problem, but what does it represent? What does 0 plus 6t represent for the minute hand?
It represents the angle that the minute hand makes.
It represents this angle that the minute hand makes with this imaginary line that runs from 12 to 6. Okay, so that's the angle of the minute hand.
So,
Minute angle, I'll recall it. What is the hour angle in this problem?
It starts at 90.
Okay, the hour hand starts at a 90-degree angle, and it moves how fast?
Plus t over 2. It's half a degree per minute.
Half a degree per minute. Okay, great. So we can write down an equation that tells us here's the angle that the minute hand makes. It starts at 0 degrees and it moves 6 degrees a minute. Why does the minute hand move 6 degrees a minute?
Because it takes it 5 minutes to go one of these 30-degree pi wedges.
Okay, it takes 5 minutes to move 30 degrees, so that means it's moving 6 degrees per minute. The hour hand starts at 90 degrees and it moves half a degree per minute because it takes 60 minutes to move one of those pi wedges. Now, what can you tell me when the hour hand and minute hand are making the same angle?
Well, the angle that they make is the same with this imaginary line.
Okay, so what does when they make the same angle or when they're on top of each other, what can you tell me?
6t equals 90 plus t over 2.
Okay. These two equations have to be the same at this time. Now wait 1 second. We think this is about 16 minutes after 3 o'clock. Okay, and that was our guess. It's about 3:16. Let's just see if that guess makes sense. What is 6 times 16, do you know?
60 plus 36, which is 96.
96 equals 90 plus 16 over 2, 98. Is 96 close to 98?
Yeah, very close.
Yeah, so it looks like our guess was close. So let's solve this equation now and see what we get.
So this becomes 6t minus t over 2 equals 90. Just plug it over there.
Yep.
So 6t is 12t over 2. So 11t over 2 equals 90. So 11t is 180.
Okay, so what's t?
T is 180 over 11.
T is 180 over 11, and that represents the minutes after 3 o'clock. Okay?
Let's figure out what...
Now, we can do this division very quickly. 11 into 180, 11 into 18 is?
Once.
That brings down an 11. 18 minus 11 is?
7.
7. 11 into 70 is?
6 times.
6. 70 minus 66 is?
4.
Are you sure?
Yes.
Have you seen that somewhere? Okay, 11 into 40 is?
3.
And 30 33, that leaves us 7. 11 into 70.
6. 36.
Okay, so this is going to keep going. So we did get 16. Look, we guessed 316, and it's actually a little bit after 316.
It's about 316 and a fourth. No, 316 and a half. No, it's not. It's 316 and a third. Pretty close.
There you go. It's
pretty
about
close.
it's a third would be 0.33333, right?
Yeah.
So it's pretty close to 316 and 1/3. Okay. So there you go. So what's the procedure that we look at on these problems? Okay. So we have a little clock problem. Great idea to draw a picture. That's why I drew the picture first, so we didn't have to waste time drawing the picture. Then draw the picture of where you think the hands are going to be, so that you can get an estimate. We think it's going to be about 316. So if we got that it was actually like 345, we'd say, well, we must have made a mistake. Okay? Next, set up your equation for what the angle the minute hand makes. Next, set up your equation for what angle the hour hand makes. Now, from the picture, we can see that these two things have to be equal. These equations have to be equal. And we can check that they're about equal at our guess by plugging in 16 minutes into here. Then we just solve the equations, and we get the answer is about 316 and 0.363636, which is 4/11ths, or we can say it's about 1/3 of a minute after that, which is about 20 seconds. Okay?
Yep.
All right. Good job. Good job, Steve.